Well, thank you. My name is Gabriel Rojas. I'm from the University of Innsbruck. I work for the department or the unit for energy efficient buildings. That's part of the technical faculty of the university here in Innsbruck. And I'm also affiliated to the Digital Science Center, which is also part of the University of Innsbruck. And today I want to surely share our first experiences and results from this project. We called it DIGIdat. It's about evaluating different, well, first evaluating the indoor air quality in Austrian schools and evaluate different improving potentials for the indoor air quality. So it's about indoor air quality in schools. It's a citizen science approach, as you may figure, as this is the working group. But what was the motivation? So we wrote this proposal a couple of years ago, and that was in the plan Corona time still. And certainly that helped, I guess, to motivate it and to make it more that people were more aware and conscious about this indoor air quality topic in schools. We know you probably in your countries also you've there were in the media, and if you've talked to teachers, there were plenty of guidelines on how to ventilate the room correctly, the classrooms correctly. So there's a bunch of screenshots I did there. So this was quite a hot topic, but actually in our department, this issue about indoor air quality in school is not a new one. So in Corona, was all about not being infected, but in general, there are studies that are quite old, and there was this issue about underventilated classrooms and bad indoor air quality in classrooms. So there's a bunch of studies. I picked out some here. This figure here is from 2008. It shows a study where 18 classrooms were measured, and 16 out of them had a CO2 concentration. So that's the typical proxy that is used for indoor air quality. The CO2 concentration, as you surely know, was above the guideline value. Also from other studies, international studies, similar results. In conclusion, or many of the studies conclude that the air exchange rate in the schools is too low to ensure good ventilation and good air quality. So the motivation for this study was to figure out what is the situation now in Austrian schools. I hadn't found any, in particular, any study on the western part of Austria. That's where we are in Innsbruck here. And but certainly a pressing issue, a pressing question is what to do with existing schools. So I think in Austria, although it's not fixed or written in stone, just some days ago, actually, the Ministry of Education gave a statement saying that all new schools will be built with mechanical ventilation, but it's not somewhere written in stone or in a law or something like that. So, but I think this is rather undiscussed. The big question is what to do with existing schools, and when it comes to refurbishment, how should they be refurbished? Should there be is window airing enough, or should mechanical ventilation be installed? So this was the motivation for this project to give some numbers on that, evaluate them, how that they perform in real life. So so the research question, as I said, is about what is the indoor air quality, and how does it depend on the ventilation concept, and how do the different improvement interventions, like we call them then, like raising awareness or installing a CO2 warner, one of those traffic light systems, or installing a ventilation systems, how do those interventions perform in real life? And we chose the approach of going this on a citizen science project, so involving the students and the teachers in that. And so to have we wanted to have the two sides. to gather like scientifically relevant data, and at the same time also raise awareness under the students or pupils and the teachers, of course, and the principals of the schools, and also the stakeholders. We have planned some project meetings where we invite different stakeholders, like architects and building designers or HVAC designers, but also the authorities who own the buildings, and to inform them and give them guidelines. So this is our core project team. So as said, University of Innsbruck, Simon is here also. He's in my department. And he does, I would say, most of the work in this project. And then we collaborate with the, in English, Pädagogische Hochschule, so the University for Teacher Education. I'll translate it like this for now. So they bring their input on the didactical part. And then we have some project partners. Komfortlüftung, they are very well connected and know the mechanical ventilation industry well. Let's put it that way. Then Open Sense Lab is they helped us with this with the sense boxes, the sensor kits we used, and then this other one is a non-profit organization about raising, or how would you say, about architecture and the connection between architecture and citizen science, let's put it that way. So what we do, or what we did, what we do is we measure the air quality in 10 schools here in the province of Tyrol. That's western part of Austria. And so it's schools, middle schools, I guess you would say, or high schools. So the participating pupils are around 12 or 13 years old, except for one school where they're a bit older, the technical high school. But most of them are around 12 and 13 years old. And the concept of this project, or the project idea, is that we have different workshops with the pupils, and they help us gather the data. So the idea was to give they form teams, and the teams of pupils, usually 2, maybe 3, they're responsible for one sensor kit. So the idea is that because we have heard that from other studies that placing sensors somewhere has the difficulty or the challenge sometimes that the sensors disappear, they get unplugged, they get destroyed and things like that. So we wanted to give them the responsibility, the ownership, and with the hope that this aspect would improve. So in fall or winter, we started with this first workshop here. Then we placed the sensors. Then we started. The measurement started. I'll tell you more about the steps. And now we're in the process, or we are performing the second workshops now before the end of the year. And then before the summer break, we want to, or we're planning a workshop with the stakeholders about possible interventions. So I'll go through the steps a bit in detail. So this workshop with the students or with the pupils was about programming the sensors. So well, of course, first we introduced them to the project and introduced them to the concept of energy efficient buildings and what is indoor air quality and the importance of it. And then we had them program the sensors. So I'll show you the sensors later. They can be programmed easily with this Blockly language. And then they assembled it to a sensor kit, and as said, in teams they took ownership of those. So there on the left you see here a kit where we have a housing that we developed here and printed it in 3D. Most schools chose that option. We gave the option, either you build it yourself with your students, in the crafts workshop thing. And I was expecting more participation there, but most schools chose the easy way and said, "Yeah, please, print it, have it to be printed, and you bring the housing." One school decided to have the kids build their own housing. This is an example. So they did this with woodwork and put a plexiglass on top for protection, and so we had that also, but um, not too often, as said. The sensors we used are based on the SenseBox initiative, if you want to call it like that, a company. It's a little spin-off from the university, German university in Münster. It's Arduino based, so the microcontroller is Arduino, and they have created this plug-and-play system where you can hook up different sensors, and we equip our sensor kits with a CO2 sensor by Sensirion. It's a well-known sensor that's often used in the indoor air community, I would say. Then we have this environmental sensor from Bosch, which measures the VOCs or some proxy for the VOCs, and temperature and humidity also. And then not in all kits, but in at least one kit per classroom, we have one also equipped with a particular matter sensor, also from Sensirion. The programming, as said, is, and that's the main reason why we chose this SenseBox, is because it's already configured plug and play to be able to use this Blockly programming language, which works, in our experience, worked quite well with the kids. They were enthusiastic about programming them, and they're quite fast learning. Some of them didn't have programming experience, but with this Blockly, it worked quite nice. And so we, mostly Simon and Elena from the from the Pädagogische Hochschule, they developed instructions and put them on our project webpage where they could click through, and we were there helping them also, but they could go through the instructions step by step, and they had 3 difficulty levels. So the faster ones could try some other things with the sensors before they go on, and the slower ones, they just did the basic thing. So they had to assemble the electronics, then test, make the LED blink first, and then hook up the first temperature sensor, see if it reacts, and then hook up the other sensors, maybe build, an if then option, and things like that, and make small tests, and then connect it to the internet, and have the data sent to the open sense map. So this is also what makes this SenseBox attractive for us. So there's this cloud already there, and it was easy to set it up. So Simon had to do quite a background work before the workshops, setting up, with all the API thing and the keys that you need to access the open sense map. But once that was done, the kids just loaded parts of the necessary parts of the code in there, and then it worked out all right. But Simon can say more later on that if there's questions. And then they had to assemble, the whole thing to a sensor kit and put it in a housing. Initially, we thought we would have the kids, or we would do it together with the children to put the sensors in the classrooms. We learned that this would be probably too difficult. So we chose to install it ourselves, and the work behind it was we had underestimated it at the beginning, I would say. It took us quite some time. So we so we went into 10 schools, and we had 15 sensor kits per school. So we chose to equip, put 3 sensors or 3 sensor kits in each classroom, more or less. to have redundancy mostly. That was also because of the question, where's the best location to measure, and also to have redundancy on the measurements. So as we called our participating students, we call them young scientists, the one that programmed the things. We placed sensors in their classroom. So one at the back of the classroom, one in the side wall, so where the door usually is opposite from the windows, and one near the teacher in the front wall usually. Um, we used one sensor to put somewhere outside to measure the ambient conditions, and then the remaining sensors were put in 3 other classrooms. Usually, maybe we equipped also like the room where they do handcraft work and things like that. But the goal was to install it in 3 other classrooms, so where the students weren't exposed to our awareness raising and things like that. So that was the placing of the sensors, and this we started measuring. I would say I think we installed the first ones end of last year, but most of them then were finished in January. Most classrooms were equipped with the sensors in January and February, and from then we have the continuous measurements. And so this ownership of the sensor kits by the students or by the kids included that they need to look after it. So we've created Simon created this dashboard where they can look if their data is transmitted. They can look at the Open Science Map also, but this is a bit more complicated. You have to find your sensor and things like that. So we have created on our project webpage this dashboard where they can see if their sensors is delivering data. And once a week, they're supposed to fill out a report saying what the status is. They need to check if it's still powered up, if it has Wi-Fi connection, there's a little warning lamp. If there's not, and if the housing is broken and things like that. Um, the participation in that is, I would say, so, but Simon can probably say more on that. Um, there, it depends very much. We've learned on the teachers and how they are behind, the reminding the children to do their reporting, and so they can do this report online also on our project webpage. And then my colleagues from the education university, they developed a survey, online survey, where the kids guided by the teacher, supposed to fill out a survey on the perceived indoor air quality and the perceived comfort. So we want to connect that then later, but we haven't done that so far. But and that is about every 3 to 4 weeks they fill out this survey. To improve or to get higher motivation from the children to look after their sensor kits, we called out a little challenge. We said the amount of data points that you gather, and we compare that between the different schools, the participating schools. So as you see in this dashboard, this is what this says: who gathered the most data points will be will win an entrance to one of those um, attraction parks, I call it, or there's a park with a lot of trampolines and things to jump around. So this is quite popular in the with the children right now. So we will give an entrance for a couple of hours there. So hoping that with that they're more motivated. And as said before, so now we're in this workshop phase 2, the spring workshop, as we called it, where we're going into the schools again after some months of measuring, and we repeat a bit we recap what the project is about and do the survey with them again, and then do a little data analysis exercise with them. We have them, we look at the data together, how the CO2 concentration evolves, and try to find, the events where the window was opened, and so they help them understand the data they measure. And that's the first part. And in the second part, we do what we call the building rally, where we have the children gather information that is also useful for us. So we have them measure the classrooms and draw us a little layout of the classroom, measure where the windows and the doors are, document how they're used, and also have them gather information about the buildings or the construction type. We send them to the, to the house. How do you call them? To the maintenance personnel of the school to ask them about the heating system and things like that. So that also helps us, because then we have this meta information about the measured classrooms and the school all together. And as said, so now this first year was all about measuring the as-is condition. Of course, in the one classroom where the young scientists are, there already maybe there's some awareness raising already that happened there, but all in the other classrooms hasn't. So now going into the second and third year, then we want to introduce some sort of intervention that could improve, possibly improve the indoor air quality. And so we have different intervention concepts that we've put as an idea out, but we want to discuss those within this workshops where we invite different stakeholders. So we invite the teachers, we invite some students to children to present some of the results, but we won't be able to invite all the children. But the idea is that so the teachers, the school principals are there, and also representatives from the Department of Education, the building owners. In Austria, the buildings are either state-owned or owned by the city or by the local government. So invite representatives from them, and also architects that we know that have that are known for designing school buildings, and also HVAC designers we have invited. Of course, HVAC manufacturers, so manufacturers of ventilation systems, they are interested. We have, of course, they're interested that they try to convince many that the schools should be retrofitted with those. So we have some also sponsoring equipment for the retrofit of some classrooms. We're planning to have 2 or 3 classrooms retrofitted with the mechanical ventilation systems. If we get, we're still trying to organize also to install automatic window opener as an intervention strategy. So, one of those things that is controlled by a measurement of usually CO2, also of carbon dioxide, and opens automatically. And then, of course, the simpler one that we will implement with our sensor kits, they have a LED on there, a light on there that can be programmed. So we will program with the children a warning light with the existing sensor kits and put them in the classrooms as another intervention strategy. And then the simplest would be just raising awareness, maybe have the young scientist class design a poster or present something in the different classrooms and raise awareness within the school to ventilate more. So that's about the project. Now I want to show you the preliminary results of the measurements we've done from January till today, basically, or till I think this graphs I'll show you were produced in end of April. yeah, just again, in case you've missed this, so the sensor kits send the data to the Open Sense map, which is this public data cloud that's run by people around this SenseBox. And we also download the data from there and visualize it on our own project webpage on this dashboard, so where the children can go and see. So we regularly download the data, and Simon has written an analysis script in Python, so we process the data in Python. And as said, we measure temperature, relative humidity, the VOC equivalent from this Bosch sensor, then the CO2 concentration measured with the infrared sensor, and the particulate matter, so the PM, in a sampling interval of 1 minute. The first month we had problems within 1 minute interval, and we switched to 4 or 5 minutes. We had to learn the hard way that the Open Sense map didn't accept this high data rate. If we had 15 sensors coming from the same IP or from the same network, then the Open Sense map would block and not accept because the data rate was too high. But that was fixed by the people from the Open Sense map. So now we're storing in a 1 minute sample interval. So what you see here as an exemplary case, the measurement of CO2 in a classroom that's ventilated by air, so manual window airing like most classes are, but we have some schools that are equipped already with mechanical ventilation, and you see here an example in the red one. And as you can see also already, the CO2 concentrations are quite high. So this is another example for a school with window airing, so no mechanical ventilation. And you see a week here, and the daily spikes, they are well above 2,000, 2,500 almost. In this day, even above 4,000 ppm. So that's quite well above, the guideline value of 1,000 ppm, 1,500 that we want to stay below. This is the result, more summarized in a box plot of the measurements we had up to end of April, I think. So you see in blue but for this first analysis, we did this categorization, or we looked at the difference between window airing and mechanical ventilation. So you see on the right, the blue ones, window airing, and on the right, the mechanical ventilation. You see that the standard deviation is much higher on the window airing. It depends much more, of course, on the habits and on the discipline on how the rooms are ventilated. There's a standard deviation also, or a deviation on the mechanical ventilated ones, but quite smaller one. And there's also some that don't work as they should. We have identified this one. We're in the process of trying to figure out if there's a technical problem there, and if so, what it is. We have a suspicion already what's going on there. But one can see that the CO2 concentration as a proxy for indoor air quality is a bit higher, or quite a bit higher, in manually ventilated classrooms. You can see that here even better if we look on the right side. So again, the blue ones are the rooms with window airing, manual window airing, and the red dots are from the schools with mechanical ventilation. And we plotted that against ambient temperature. And you clearly see that as the temperature gets colder outside, the ventilation discipline gets worse and worse, because we've got that feedback, of course, also from the teachers and the students there, that the people we had this in our workshops, we had these games, and we asked the people, and of course the people, the students or the children sitting next to the window, they said they complain about being cold. So you can see that in this data already quite nicely. On the left side, you see the particular matter concentration, so the PM 2.5, and plotted, so the indoor measured, the PM 2.5 concentration measured in the classrooms versus the PM 2.5 concentration measured on the outside. And you see also how the mechanically ventilated ones, there's not many data points yet, so we hope to gather more, or we are in the process of gathering more data points here to solidify this this result. But it seems like this first graph here indicates that there's as ambient concentration goes up, the indoor concentration goes up stronger in window ventilated rooms. As plausible result, because of the mechanical ventilation have a filtration system that should take care of most part of the ambient particulate matter. Yes, well, with that, I'm at the end, and I'm happy to discuss any questions or comments, or hear about your experiences in projects like that. Yeah, if you have more questions on.
Yeah, thank you very much. It's a wonderful presentation. It's a lot of information. So I'm sure there must be a lot of questions. Who wants to kick off? Or else I'll kick off, because I have a lot of questions. This, one of the questions is like, you showed a lot of results, and of course this is a citizen science project. So there is also the school children doing science, and you are doing science, right? So can you tell a little bit more about what kind of questions the school children were answering, or trying to answer? What were the scientific questions they worked on?
Well, for now, I would say to measure or to obtain, what is the indoor air quality currently in their classrooms. So that's the first question they had to answer, and that's by having their sensors, by running their sensors. But it's probably not, the way we set up this project is probably not so much that we have them work on a scientific question by themselves and provide that. It's more, we see it as a combined effort, and working together. So they're helping us program the sensors, maintain the sensors, and then in the second workshop we look with them together at the data, of course in a simplified way, with and have them understand what the measurements results are saying. So this together, then we're trying to answer the question, how is the indoor air quality in your classrooms, and what makes it better?
Yeah. So you also do a survey about what kind of effect it is on how they feel, whether they get a headache, or is that also is that part of your research, or part of their research, or part of the research together?
Yeah, I would say part of the research together. Or I would say, they're 13 years old. We're trying to keep it simple for them, I would say. So the correlation between the survey that we are doing on the perceived comfort and perceived indoor air quality and the data, I would say the correlation of that, we won't be able to do that with the kids. I think that would be too much. We go into the schools in those 2 workshops, and those are, the first workshop was around 4 hours or 5, split it up sometimes into some modules, and the second one is also like 3 hours or so. So there's not that much time, so we have to limit it, or we're limited on the things we can do with the kids, and so we try to keep it simple. And in between, we had some ideas on work things that we give them to do, but we've realized that to some extent, some schools, some teachers are behind that, but we are too dependent on the teachers and them being motivated to do that with the kids. And so we said we need to, the thing must be set up in a way that we don't rely on those works being done in between the workshops. So we only want to rely on the things that we do while we're there with the children in our workshops.
Because how does it fit into the school curriculum? Is it an extra project, or is it part of a certain subject that they are? I don't know how that works in
Yes, well,
Austria.
this project, I should have said that before, is funded by a framework for for citizen science project. It's called Sparkling Science, and so it's an extracurricular thing. So it was about finding schools that are willing to participate and finding teachers that are willing to participate, but they have to build it into their curricula somehow. So I think many of the participating teachers are teachers for what do you call that? Handcraft, or
Oh yeah.
and we at the beginning of the project, I at least had thought there would be more also teachers participating from physics or from informatics, but only in a few schools that's the case. Most of them are really from the teachers that do handcraft. I think that has to do with the connections that our partner from the education university has to the teachers. So they have to build that in, and there were some complaints there, or I heard some complaints saying that we can't use too many of our hours. Their hours has been cut in the last years already. They're having a hard time to bringing all the projects where they build things in school with the kids to get it all through and make their curricula. So they said, we're limited on what time we can give you for your project. So that's also a reason.
Yeah. Okay. Interesting. Maybe you should stop sharing and we can see some faces and see who else wants to comment or has a question. I see David.
Yeah, hello. I just had one question. We often have problem here in France with the parents who are afraid about, bad news about air quality. So did you handle any, communication with the parents, or it was just mainly with the kids and the teachers? And if there was problem, or, if problems were identified, how, did you handle them?
We had no direct contact with the parents. We had just we put together an information letter that was sent home with the children, so that they're informed that their kids are part of this project or participating in this project. But no, so far we haven't had any direct contact with the parents. And yeah, I mean it has been in the news, but it's still not, or at least in my sense, it hasn't arrived in the awareness of the general public and the parents about the importance of indoor air quality in schools. It has been a topic during Corona, but it was, I think, in the parents' minds, it's limited to infection transmission, but it hasn't arrived that the cognitive performance of children is affected by the indoor air quality. So I think, or we hope to raise awareness also with this project. But
anyone else? Oh, I see Clara raising her hand.
Yes, hello, thank you. Yes, I have a question because we are also planning some studies in school more focused on microbiological assessment of the air quality, but we also want to have some questionnaires how the indoor air quality is perceived by the pupils. So I wanted to ask if you said you will do this, you haven't started yet, and you will ask this every couple of weeks. How many questions do you plan here, or how complicated? Because this was something we were thinking about, that this shouldn't be, too much, because if it's a questionnaire, it takes a lot of time to fill out, and maybe the pupils won't do it.
Yes, we thought about it quite a bit. Actually, I don't know too much about it because my colleague Sebastian, his professor at the Pädagogische Hochschule, he took care of that. We actually are already in the process of doing the surveys. I said we haven't analyzed the data yet, but we started that already.
Okay.
I don't know, 2 months ago or so. And but the basic concept is so in the repeating thing, we always ask, we'll have them, log in with the user ID that they set the first time. It's set up that it's anonymous, but that in the repeating sense, we know who, we know the answers from the previous round, so that those get connected together, so they have an ID where they log in, and then they always do that, and they answer questions, simple ones and only a few ones, on how they perceive the air quality and the comfort. And then each time there's a different focus then where there's additional other questions about I think socioeconomic things, and one time, and the other time some other things. But if you are interested, I can maybe ask or give you the contact of my colleague, and you can call him directly and have him tell you the challenges and the solutions we've found.
Yes, this would be great if we could already get some information and go along with already your experience then next year. Yeah.
Sure, maybe you can, I don't know how this works here, or you can send me your email. Did I put my email here? No.
But I think I will find you from the
you can find me.
university and so on. So you put the name. So I will find you. I will send you an email. Great. Thanks.
Oh, that's a great idea. Exchange those things. I think it's quite hard to make a good questionnaire.
Yes, I agree.
Can you tell me a little bit? Oh, I see David. Can I ask just before David? Can I ask you a little about the sensor box? How expensive is that?
Let Simon talk on that. He knows probably better on top of the head than me.
They're about 150 euros when we first bought them, and I think now they're 200 euros or something like that. The more expensive versions of the boxes with the particulate matter sensor are 50 euros additional. That's around it. Yeah.
Okay, well, it's not too expensive. Interesting. David, you also wanted to ask a question.
Yeah, it was. Did you at some point try to combine information with outdoor air quality in order to have smart ventilation based on how polluted it is outside?
I would say this is not the focus of this project, but you know, I have other projects more on residential ventilation where it's about that, you know, smart control schemes for ventilation. But there in this project, we're definitely looking at the correlation, as I showed you in the results between the ambient and the indoor concentration, and we want to look at that also. I'm not sure if we have enough data points to look also in Tyrol, Western Austria. So it's a transit regions. You know, much of the transportation. So the lorries and the trucks going from north to south pass by our valley here, and so there's more affected areas that are strongly affected by particulate matter than others. And we, if we have enough data point, we'll also compare, you know, how the indoor air quality is different from the different locations that have worse outdoor air quality also.
Okay, thank you.
Any other questions? Silence on a lot of people muted and not visible. Okay, if those are all the questions, I guess we are thanking you for a very nice presentation. I liked it very much. I like the box very much. I like the results. It would really be interesting to know how much of this could also be exported to other countries, right? Because like the questionnaire is already a nice example, but the whole approach of how you do that, is there information on that, or?
Well, we're planning, or it's part of a project, but towards the end is to we called it, you know, to enable multiplying the things. So we are planning to, you know, share the codes that Simon has written to extract the data and the surveys and things like that, and the materials for the workshop. That's was quite some effort that we've put in to share that, and you know, for teachers or schools that are motivated to have you know, buy those sensor kits and have all the material that's we used available for them. So yes, we're planning to do that, but towards the end of the project.
Mm-hmm. Yeah, that sounds wonderful, because there must be, it's just very relevant for all schools across the world, I suppose, just to know when to open Windows and to be able to measure it yourself for, I don't know, less than 200 euros. That should be really be very attractive, I suppose, for many schools.
Yeah, we are hoping for how do you say, repeaters, or
yeah, that would be a great idea. Anyway, we're almost, our time is almost up, so I would like to give one last possibility of asking question. And if not, I would like to thank you very much, Gabriel and Simon, for being here and giving this great presentation. I will stop the camera